calculate the second moment of area of the plane figure bounded by the y-axis and the curve y squared is equal to 4 minus x with respect to the x-axis. Okay, so now be careful, this is not a circle. Just because you see y squared there, it's not a circle. If it was a circle, there will also be an x squared here. Okay, circle will have x squared and y squared in the same equation. So now, here you got y squared is equal to 4 minus x. If I have to manipulate this equation, I have y squared is equal to 4 minus x. If I make x the subject of the formula, so then x is going to equal to 4 minus y squared. Or you can write it down as x is equal to minus y squared plus 4. What graph is this? You got a minus y squared. If I remove the plus 4 there, x is equal to minus y squared is a parabola. Remember, there are 4 parabolas. There's one with x squared and there's the other one with y squared. What is the coefficient of y squared here? Negative. Remember, positive will be facing the right, negative will be on the left. So what's happening is you are taking minus y squared, your normal parabola, plus 4 means you are shifting it 4 units above, 4 units to the top. Okay, it's just having a vertical shift 4 units to the top. But now, let's look at a technique to sketch these types of graphs. So, we are used to working with a parabola where it's in the form y is equal to and you have an x squared. Okay, then we find our x-intercepts, y-intercept, turning point. So, there's nothing stopping you from changing this. If I swap the x and y values here, just for convenience, you don't have to do that. So let's say I swap x and y to make it easier for myself. So what will happen here? It will become x squared is equal to 4 minus y. Okay. So now if I manipulate this equation, if I take minus y to the left, it's going to be y is equal to minus x squared plus 4. So let's work with this equation, the inverse of the parabola. Okay, this is the inverse of this parabola. So now, if I have to find the x-intercepts here, that means I'm going to find the y-intercepts of my original graph. Okay, so I'm finding the x-intercepts here. So how do I find the x-intercepts? You let y equal to 0. Alright, so therefore, I will substitute 0 there. So 0 is equal to minus x squared plus 4. And then I will solve for x. If I take negative x squared to the left, it will be x squared is equal to 4. And then I will find the square roots of 4, which is going to be plus or minus 2. Okay, so let's have a look at how the coordinates are written down. X-intercepts, so therefore, let's write it down. This will be plus 2 and minus 2, so that was going to be a 2, 0. And we have minus 2, 0. Because remember, what is y on the x-axis? Y is 0. So that means when x is equal to 2, y is 0. When x is equal to minus 2, y is 0. Right, we're used to this, is simple. We can deal with this. Now, in our original graph, it won't be x-intercepts. Because remember, we swapped x and y. So, in our original graph, it will be y-intercepts. So instead of 2 and 0, you swap the position, it will be 0 and 2. And 0 and minus 2. Right, so that was the first part. So now, what about the y-intercepts? Let's go to the graph that we're familiar with. If I want to work out the y-intercept here, I will let x equal to 0. So I'll go to the original graph, the graph that I have here. So y is equal to minus 0 squared plus 4. So y is equal to 4. So what does this mean in terms of coordinates? When x was equal to 0, y was equal to 4. Now, in my original graph, what will it mean? Will it be a y-intercept? This is y-intercept. So in my original graph, what will it be? It will be the x-intercept. So I swap it back. That will be 4 and 0. Okay. What else do we need to find? X-intercept, y-intercept. What else do we find of a parabola? Turning points. Okay. So if I want to find the turning point, although this is going to be the turning point, but let's find it anyway. So if I want to find the turning points, I will find the first derivative, make it equal to 0. Or I can work out minus b over 2a. Right, but since we're dealing with calculus, let's just use calculus to find the turning point. So here is y. If I want to find dy over dx, what is the derivative of minus x squared plus 4? It will just be minus 2x plus 0. What are we going to do here? We will take minus 2x and we will make it equal to 0. Because the gradient of the tangent here will be 0. So x is equal to 0 over minus 2, which is 0. How do I find the y value of the turning points? Substitute into the original equation. So f of 0, that means I'm going to substitute 0 there. What will I get? I'll get 4. So what is my turning point of the inverse, the one that I just changed? It is 0, 4. So what will the turning point of the graph that I require? What will it be? Your turning point, if I swap it around, 4, 0. So the graph, what does this mean? The graph turns at the x-intercept. There you can see that. The turning point and the x-intercept are at the same position. Now, once you're done with all this, you can just put a line. We don't require this anymore. We just used it to make it easier for ourselves. You can see that? Let's sketch the graph. Right, so x-intercepts, y-intercept, turning point, simple to plot there. Y-intercepts are 2 and negative 2. So let's go for 2 here and minus 2 there. What is the x-intercept of the graph, which is also the turning point? 4 and 0. Let's go for 4 here. 0 there. Let's sketch the graph. You can see right, so that is our parabola, the one that we required. What is the equation of this graph? Y squared is equal to 4 minus x. Now, we have the parabola. Can you identify the area? Let's read the question. Calculate the second moment of area of the plane figure bounded by the y-axis and the curve with respect to the x-axis. The main thing is bounded by the y-axis and the curve. So where is the area that we are talking about? bounded by the curve. There's a curve here and the y-axis. Can you see the area? This is the area. Here's the y-axis here. And there's a curve. Now we have a choice whether to use dx or dy. See, most of you were using dx. Some of you were trying to work it out, but you could not get the answer. Let's see what was the problem. Okay, so let's say you want to use dx here. Okay, what do you notice about the area? Let me divide it here. Now, what do you notice about this line here? The x-axis is an axis of symmetry. Can you see that? It divides the area into two. Basically, it divides the graph into two equal areas here. The area on the top is identical to the area in the bottom. Okay, so let's call this part here area A. Area A on the top, let's call this one area B. Okay, so if I wanted to work out the total area, I have a choice. I can just work out area A and multiply by 2. Or I can work out area B and multiply by 2. It's the same as taking area A plus area B to give me the total area there. Okay, so that's when I'm using delta x. Let's say I'm using delta x here. Okay, I'm only going to deal with area A. I'm going to work out the second moment of area A, and I'll multiply by 2, it will give me the answer. Okay. So let's work with area A only. Right, so this was our area A. Let me just write that down. Now let's work with the top parts only. I could have chosen the bottom part. So now, we are not working out just second area, we are working out second moment of area. So now, here is our graph that we're going to deal with. So here, we know delta x. Now which axis are we calculating with respect to? Here's it here, with respect to the x-axis. Right, so now, delta x, how is it related to the reference axis? It is perpendicular to the reference axis. Delta x is perpendicular to the reference axis. So therefore, delta ix, if it is perpendicular, we are going to use the formula with k involved. Okay, so it is going to be area, which is delta A multiplied by k squared. But what is area? What is the length of the representative element? What is the length going to be? The breadth is delta x. The length will be y, so it's going to be y times delta x, that's area, times your k. K is the length. What is the length measured in terms of? The length is measured in terms of y, so that will be y over root 3, and that is all squared. So what happens here? We end up with y delta x times, if I square this, if I square the numerator, it will be y squared, square the denominator, that will be 3. So therefore, let's write down our total. We integrate, this is dx, that means we are integrating with respect to x, we are using b and a. Take your constants, there's your constant there, 1 over 3, y times y squared will give me y to the power 3, and that is my dx there. Okay, now, simple, what is your b and a? Remember, we are dealing with dx. What is b and a? What is the x value at the beginning of the area? The x value at the end? What's it going to be? Is it going to be 0 and 2?
No.
No. X value at the beginning, x value at the end. There you can see that, which will be 4 and 0. Then we got y cubed. But this is not dy. What is this? This is dx. So that means we need to get y in terms of x. Now, that's y cubed. So, what is y? What is y here? This is y squared is equal to 4 minus x. Okay. Or this can be written as y is equal to plus or minus the square root of 4 minus x. That is the equation of the parabola that you see. But am I dealing with the full parabola here? No, I just took the the top half, which is area A. What is the equation of this graph here? What is the equation of this curve only? This is on the positive side, y can only be positive here. Okay, so here y can be positive and negative. Here y can only be positive. So this will just be the positive square root of 4 minus x. That is the equation of that curve there. Can you see that? So now we substitute. What is y? Y is the square root of 4 minus x. Now, I have to obviously, now comes the N5 parts. This is the N6 part of the problem. We needed to sketch the graph, we need to understand the area, we need to know which formula to use, which is based on my diagram here. You can see that. So now, it's just integration. Simple. Simplify first, integrate second. Well, let me give you a few minutes to simplify. Right, so here we got the square root of 4 minus x, which is the same as 4 minus x to the power half, and the whole thing is raised to the power 3. So we have our exponent law, a power raised to a higher power. What do we do? What do you do when you have a power raised to a higher power? You multiply the exponents. 1 over 2 times 3 will be 3 over 2. Okay, so now this is type A from N5. F of x to the power n. This is what we are dealing with here. F of x to the power n multiplied by f prime x. Okay, so how do we deal with this? We always let u equal to f of x. In this case, it's 4 minus x. Okay, I'm not going to do that. Simple thing to do. Find du dx, which is minus 1, make dx a subject. If you didn't recognize that, then your problem is the N5 integration. You need to go back and you need to do maybe hundreds of examples. Okay, So here what is going to happen, you're going to end up with minus 1 over 3, and that will be 4 minus x, 3 over 2, that will be 5 over 2, 2 over 5. That's 4 and 0. I'm going to simplify this here. I'm going to take this out, so that will be minus 2 over 15. And then we have 4 minus x to the power 5 over 2. Right, so that was our integration. Let's substitute. We got minus 2 over 15. If I substitute 4 there, we don't need a calculator for that. 4 minus 4 is 0. 0 to the power 5 over 2 is just 0. So that will be a 0 minus, when I substitute a 0 here, I'm going to get 4 to the power 5 over 2, which is actually 2 squared to the power 5 over 2, which will just be 2 to the power 5, which is 32. Okay. So now, I got my minus 2 over 15. 0 minus 32 is minus 32. Multiply that. Simple, that will be 64 over 15 units to the power 4. So now what did we work out? We just worked out the second moment of area A. Right, so remember that area A is equal to area B. Area A is equal to area B. So the total second moment of area that we need will be the second moment of area here that we just worked out. So let's just write that down. Ix of part A plus Ix of part B. But what do we know? We know that area B is equal to area A. So that means I can change this to A because A is equal to B. So therefore, I'm going to get twice from adding. These are like terms. You can see that 1 plus 1, that will give you 2 of Ix. So what did we just work out now? We just worked out our second moment of area, which was 64 over 15. So 2 times 64, you get 128 over 15. That's units to the power 4. 128 over 15, what was the answer there? That's it? Just 8,33. That's all. 333 units to the power 4. Right, so that was understanding when your graph is symmetrical about the x-axis, you have identical area. Now, what about using delta y? Right, so the other option of working this out will be using delta y. If we had to use delta y, then delta y is now parallel to the reference axis. Okay, delta y will be parallel to the reference axis. So therefore, delta Ix, second moment of area, will equal to area, which is delta A, times the distance from the x-axis. So what is the distance from the x-axis? What are we measuring in terms of? If we measure from the x-axis, there's a reference axis there. You can see that it will be in terms of y, so that will be y squared. What will the formula for area be now? Now we are not splitting it up into two. We're just using the full. We are using the full area now. The length from here to here, what is the length of the rectangle? The distance from here to here is measured in terms of x. Okay. So, that will be x times dy multiplied by y squared. There's area times your distance squared. So now, the total. If we are using delta y, we're going to use the y values. That will be d and c. That will be x times y squared dy. What are the y values that we're going to use here? What are the y values at the beginning and the end of the area? You can see the lowest point here is -2. The highest point there is 2. So that will be a 2 and a -2. But now this is dy. That means we got a problem now. Can you see that? We need to replace x. What is the equation of this parabola? What is the equation of the parabola? It is y squared is equal to 4 minus x. But what do we want here? We want to replace x. So what will x be? Manipulate that equation in your head. You don't need to write that down. If I have to manipulate this equation, what's it going to be? It's going to be 4 minus y squared. We are not using this, we are not rewriting it in terms of the square root there. You can see that. We are using the full parabola. So, this is going to be much easier now. You can see that. All we have to do is multiply. So this will equal to, here's your 2 and minus 2. Simplify first, that will be 4y squared minus y to the power 4. That's your dy. The integration here is, sorry, this was 8.533. This was not 8.333. Alright. But everyone said yes. I don't know. Did everyone write down 8.533 or 8.33? 8.533. Okay. Let's get back to where we were. Alright, so here we multiply, we integrate. So this will be 4y to the power 3 over 3 minus y to the power 5 over 5. This is more like your N4 type integration. That was more like N5 type. Can you see that type A depends on the choice that you make, depends on the diagram. If you cannot sketch a graph, then obviously you're not interested in learning how to sketch graphs. At N6, you had enough time. I told you in the beginning to go over your graphs. So that's your 2 and minus 2. So we substitute 2 When you substitute 2 here, what do you get? Who's fast? Just give it to me quickly there. Substitute 2, let's see. What do we get here? What do we get?
64 over 15.
Yes, you must get 64 over 15. Minus. Now when you substitute minus 2, what do you get? You must get minus 64 over 15, which is correct. So now, that means you got 64 over 15 here. That will be plus 64 over 15. You can see you've got an LCD of 15. 64 plus 64 will give us 128 over 15 units to the power 4, which is the same 8.533 units to the power 4. So this technique is using delta y. We get the entire area in at one go here. You can see that. Here we use delta x. So we understood that the graph was symmetrical about the x-axis. So we double the area that we found. Okay. Right.